In this video, we will look at graphs of motion. In each scenario, we will look at three different graphs, namely position time graph, velocity time graph, and acceleration time graph. Miss Landi was in the mood for ice cream. Since she was on a diet, she had to sneak out to eat it. She stood under a tree that was 700 meters east from home and ate her ice cream in 10 minutes. Draw the three graphs of motion to represent her motion for the 10 minutes she ate her ice cream. Position time graph. Let the y-axis represent the position in meters and the x-axis the time in seconds. The entire time axis represents the reference point. So in our story, it will be Miss Landi's home. Since Miss Landi moved east, we will take east as positive. So we will draw the graph to the positive side from the reference point or the time axis. Remember to convert the 10 minutes to seconds by multiplying it by 60 to get 600 seconds. Miss Landi stands still while she eats her ice cream, meaning she is at a constant position. To represent this constant position on a position time graph, we draw a horizontal line from the 700 meter mark on the position axis to the point where the 700 meter and 600 seconds meet up. Velocity time graph. Let the y-axis represent the velocity in meters per second and the x-axis the time in seconds. Since we took east as positive, let the positive y-axis represent east and the negative y-axis represent west. Since Miss Landi is at a constant position, we know that she is standing still, so her velocity is 0 meters per second. We can represent this constant position on a velocity time graph by drawing a horizontal line on the time axis at 0 meters per second. Acceleration time graph. Let the y-axis represent acceleration in meters per squared second and the x-axis the time in seconds. Since we took east as positive, the positive side of the y-axis represents east and the negative side west. Since Miss Landi is at a constant position, she has no velocity, so there can be no acceleration. To represent this constant position on an acceleration time graph, we draw a horizontal line on the time axis at 0 meters per squared second. Stay tuned for the next scenario.